This is on the slightly simpler side. The problem is to convert from integer to Roman numerals. This is a question that I myself asked in an interview long back. But it's an interesting question in that it allows for some exploration, but then the question itself is pretty simple. This is what the interviewer tells you. Convert an integer, write a function or write a method to convert an integer to Roman numerals. What's your thought process? What would you tell the interviewer? What would you ask the interviewer? All right, the question. Do you want to assume only positive numbers? Yes, that's a great question. Assume only positive numbers. I don't know if Romans had the concept of a negative number. I'm sure they did subtraction, but I don't know if they had the concept of negative. But anyway, it's assume just positive numbers. Should it be a string? Yes. The result should be a string because Roman numerals can be represented only using string data types. You cannot have an integer. The candidate can ask, what are Roman numerals? That's a fair question. I don't live in the Roman times. Hey, interviewer, tell me what a Roman numeral is. It's perfectly fair. So, Roman numerals are basically numerals that were used by the Romans, and they used certain symbols for certain numbers. The Romans had a lot of things going for them. The one thing that they didn't have was the concept of zero. They didn't have the ability to append zero to a number and then change what that number means, right? So we have the digit 1, and then we can append a 0 to it. And depending on the position of that digit 1 in the number, the value of that number changes, right? That's the power of the 0. But Romans didn't have that concept. They had kind of like a one-to-one mapping of symbols to values, right? For example, they had the symbol x, which means 10. And irrespective of the position of the number in that whole numeral, x always meant 10. However, position was important in what you would do with that number. All right, so here are the symbols, right? We've got I, which means 1, and then V, which means 5, X, which means 10, L, which means 50, then C is 100, D is 500, and M is 1000. Right, these are the numerals. And like I said, these are position based. Now, let's say I want to convert the digit 1 to Roman numerals. Just say I. And then you want to convert 5 to Roman numerals. Just say V. How about 2? There is nothing in between 1 and 5, right? So the way to do this is by handling using repetition. So 2 is basically 2 I's, right? 2 is essentially 2 1s. So 3 is essentially 3 1s, right? So this can get tedious. You can imagine, say 90. Is 90 equals to 10 x's? 10 x's? No, that would be too tedious. So what the Romans have is a subtractive concept, right? So this is the additive notation. They have a subtractive concept. The idea is something like this. If you have a number that just shows up like this, you're basically adding everything, right? So you're basically 3 i's, you're adding all 3 1s, and then you get 3. However, if you have a smaller notation in front of a bigger notation, all right? So this guy is smaller than this guy. In this case, you're going to do this. Let's say this is x and this is y. You're going to do y minus x, right? So for example, 4 is not 4 i's. You have I, v, right? So I is smaller than v, but then I is in front of v. So you're going to have to subtract. So it's not going to be 5, it's going to be 4. However, if I comes after v, let's say vi, then this is additive again, right? So this is 5 plus 1, is equal to 6. 100 is C, all right? So CC is 200. So let's say 300 is CCC. 400, now we can have one symbol in front of this guy, so it's going to be CD, right? C is 100, it's less than D, which is 500, so you basically need to subtract. So CD is 400. All right, so that's the challenge. That's the conversion from integer to Roman numerals. I guess the important thing is what was asked in the chat, which is the range. What's the range that you need to consider? Because we don't have, the thing with decimal is you have like infinite numbers you can create with the same symbols, right? 0 to 9, you can create infinite numbers. It just keeps going. But with the Roman system, like I mentioned, you cannot do that. You're going to run out of symbols at some point, and then you need more symbols to get to bigger and bigger numbers. So the first question that you ask is like, what's the limit that you want me to tackle? And there has to be a limit. You need to know what the upper limit is. The lower limit is obviously 1. Again, they didn't have 0. The lower limit is going to be 1. What's the upper limit? Let's say they say the upper limit is, I don't know, 3,000, all right? Because that's where you end with the M's. If you need 4,000, you need another symbol for the 5,000. So let's say the upper limit is 3,000. How would you tackle this problem? Let's say you have, let's do 24, all right? How does this convert to Roman numerals? So 10 is X, so I'm going to do 2 X's. And then 4 is IV, all right? Now, let's say I have 324. What does this translate to? I think 100 is C, so it'll be CCC, so that's 300, then 24, right? Let's say I do 2,324. You get the picture, right? So as long as these digits are the same, the corresponding Roman numeral for that position is the same. So you essentially have a way to say, okay, for this particular digit, or this particular combination of digits, I convert to a Roman numeral, and then based on the position, the value of the Roman numeral is going to change, but then that kind of gives you an opportunity to break that number down, all right? So even in this case, right, when I say 24 is the common factor here, you notice 4 is what's causing this to happen, and 2 at the 20th location, 20 is what's causing this to happen. So as long as 2 is in the tens position, you're going to get XX. No matter what is happening in this side, what's happening on this side. All right. Similarly, as long as 3 is in the hundreds position, you're going to get CCC, no matter what's happening over here or what's happening over here. So, well, that's a good observation. Is that a possible solution we can implement? Can we look at each digit at the corresponding position and map it to a Roman numeral that's going to be the same no matter what the position is? All right. This, if you were to chalk it out, and I'm not going to do this because it's going to take a while, but then once you've got the idea and you can convince the interviewer that this is the idea you're going to implement, it becomes fairly simple. Because think about it, right? So you have 10 digits per position. You have 10 digits in the units position, 10 digits in the 10th position, 10 digits in the 100th position, and then we said the limit is like what? 3,000. So 3 possible digits in the thousands position. Of course, you can have a 0, so you'll have to map that 0 as well. So probably we have to figure out where that 0 is going to go. But as long as you do that, as long as you map the 0, right? So let's say, let me show you. So let's say this is 104. Let's take the number 104. What does this map to? 110 maps to C. And then there is nothing here, so this maps to an empty string. And then 4 maps to IV. So you see, even here, 1 maps to C. So it doesn't matter, again, to reiterate, doesn't really matter. Even if it's 0, it's still the same. You're probably going to be mapping all the zeros to an empty string. So if you were to do this, if you were to map each digit in each position to the corresponding Roman numeral, this becomes super duper simple, all right? And this is the approach we're going to use. Let me show you the code. This is my method. I'm not having this class structure here because just the method will do. Takes in a number and it returns a string. I see a question which says if the number ends in a 0, do we have to handle it differently? Well, no, because if the number ends in a 0, the units position doesn't have a corresponding value in the Roman numeral. You're basically having a mapping into a string, an empty string, right? I can actually explain that with an example. So let's say you have 20, right? 2 in the tens position maps to 2 x's, like we've seen here. 0 maps to an empty string, and that's it, 2 x's for 20. So basically what I'm trying to say is it doesn't quite matter what the whole number is. You don't have to think about that, because no matter what the number is, as long as you're looking at each individual digit in the integer and then mapping it to the corresponding Roman numeral, and you're doing it for each position, things kind of take care of itself, because that's based on the position that whatever is based on a position in integer is based on symbols in Romans. So basically mapping from position to symbols. That makes sense. Let me show you the let me show you the code, and it'll probably make a little more sense. All right, so what I do here is I create this map. All right, so I'm going to create a units array. Not technically a map, but it's kind of a map because I'm mapping a number to a string value, right? So what I have here is basically a bunch of string values. 0th position maps to an empty string. 1 maps to the symbol I. 2 maps to the symbol II. 3 to III. Basically whatever we know the Roman symbols map to, right? So I've basically mapped it out for each units position to a corresponding symbol. So what I can do with just this one array is, given one number, one digit, right? 0 to 9, I can tell you what the Roman numeral is just by looking it up, right? In units of number, it's going to give you the corresponding Roman numeral. Clear with me so far? So that's the units position. So based on what you've seen so far, all you need to do for the rest of the positions is basically map out this thing. For the tens position, there's going to be a corresponding one-to-one mapping. And again, for the tens position, it really doesn't matter what's in the units, what's in the hundreds or the other side. All you need to do is achieve that one-to-one mapping. So I'm going to do the same thing for the tens position. I'm going to say tens. If there is a 10, if there is 0 in the tens position, it's an empty string. If there is 1 in the tens position, it's a 10. If it's x, if there is 2 in the tens position, it is 2x, 3x, xl for 4, because it's 40 something, right? L for 50, LX for 60, and so on until 90. 90 is XC because it's 1 less than 100, right? Remember, it's C is 100, 90 is 1 less than 100. Just like for units, 9 was 1x, which is 1 less than 10, all right? So this should be fairly simple so far. Now what I'm going to do is map the same thing to 100, same concept, and then I'm going to map the same thing to 1,000. And again, I'm mapping to just 3,000. I don't want to do beyond that. Find out whatever the limit is that the interviewer asks for. The cool thing about this is when let's say you're whiteboarding this in an interview, you don't even actually have to write this whole thing. You can just say, this is what I plan to do, or maybe just write the unit stuff and say, yeah, tens, hundreds, and thousands, I'm going to create arrays which is going to do this. And that should be good. As long as you convey the idea and your approach, you should be fine. All right, now that I have this map, all I need to do is take each individual digit and look up the value over here. It's as simple as that. So what I'm going to do here is I'm just going to return thousands of num by 1,000. So basically I'm going to get that 1,000th value, get the 100th value, which is num with the remainder of 1,000 divided by 100, which is basically getting that 100th value. You see what I mean? I can start from the units position, right? So units position is basically the remainder divided by 10, right? Whatever number you give me, what's in the unit position is the remainder of a division by 10. All right. Tens is basically one beyond that. It kind of goes back to the previous question that we tackled, which is reversing an integer, right? So you basically divide by 10 and then get the remainder of that. So it's basically number with the remainder of 100 and then divided by 10, because you don't have the luxury of a loop here, but we don't need the loop anyway. So you can try this out. Basically, it's going to give you the units position, the tens position, hundreds position, and the thousands position. And then for each digit that I'm getting, all I'm getting here with the return statement with that index is just the digit. And for each digit in each position, I'm looking up the corresponding Roman value. And then I'm adding them up. So basically concatenating the strings, right? So I'm looking up the string, then I'm adding it up, and then I'm going to get that one Roman numeral, which is formed by adding all these things up. All right. It's a fairly simple solution to what seems to be a complicated problem, which is why it's always important to think systematically. Think about like what are the patterns you can identify. That's kind of like the advantage of doing these interview questions. You may never tackle an integer to Roman conversion in any interview in your life, but then doing these kind of challenges kind of gets that thinking part of your brain working, and then you kind of tune it to tackle and identify similar patterns in some completely different interview question you may not even think about.